Assalamualaikum and good evening. Please, I would like to present about digital signal processing. Main topic is windowing filter. The code subject is BERT 3370. My lecturer is Dr. Adam Wong Yun Han. So this is my group member. My group member is named Ahmad Faris Ashraf bin Ahmad Rizbi. Code matrix is B122410526. And next is my name is Muhammad Haziq bin Muhammad B122410487. So this part first is introduction. Three filters are used in digital signal processing as they are serialized and linear-phase filters. However, the digital of an ideal filter is not possible because it is not possible to make an infinitely long impulse response, which is the ideal frequency response. In order to overcome it, the optimal impulse response is achieved using windowing method, which reduces unweighted artifacts such as spectral record and side lobe level. The objective is first to get to know the concept and the purpose of windowing in designing of field filter. Second, to demonstrate the properties and mathematical model of the hanging and rectangular window. And third, to develop field filter using both the windowing machines. Next, theory of windowing filter is an ideal filter has an infinitely long impulse response with a sharp cutoff. Such an ideal filter is not realizable in practice. Window functions are used to cascade the impulse response smoothly. Windowing results in the frequency response. Field filter is obtained by multiplying the ideal impulse response with a window function. The formula is H n equal HD and bracket n x w n. Different window types offer trade-off between side lobe attenuation and main lobe width. The choice of window depends on the application requirement. So, the theory of low-pass filter. A low-pass filter LPF allows low-frequency signal to pass through attenuated high-frequency components above the cut-off frequency, commonly used in DSP to smooth signal and remove high-frequency noise. Low-pass filters can be implemented using the or IIR filter instructors. In this project, the windowing method is used to design a filter low-pass filter. Field filter ensures linear phase characteristics and system stability. So next, ideal low-pass filter. An ideal low-pass filter frequency response is described as follows. First, unity gain for frequency load, then the cut-off frequency. Second, for frequency higher than the cut-off frequency, there is no gain. Nevertheless, an infinity impulse response is necessary for the optimal low-pass filter, which is impractical for practical application. Characteristics of low-pass filter. So the cut-off frequency, the frequency at which signal attenuation begins. Next, pass band. Frequency range low to pass with minimal attenuation. Next, stop band. Frequency range that is significantly attenuated. And next, transition band. Region between pass band and stop band. And lastly, ringing effect. Oscillation caused by acute fluctuations required by smoother window. So this application of low pass filter. So you can see in the box we have application. The first application we have 5, which is audio processing, signal smoothing, anti-aliasing in ADC communication system, image processing. So these 5 parts, I want to explanation for low pass filter. You can see audio processing remove high frequency noise to create clear audio. Which means the frequency can cut the noise to clear the audio. Next, signal smoothing. This means quickly change in sensor data to reflect the overall strength of the signal. And anti-aliasing in ADC, it means eliminated high frequencies that create aliasing before converting an analog signal to digital. Next, communication system. The explanation is remove high frequency noise in the both the receive or transmitter signal. And lastly, image processing. Provide better visual representation of image by smoothing out image and removing high frequency noises. So in this project, to send windowing filter, we have 2, which is Hamming window and rectangular window. So first, Hamming window. As the smoothing technique of digital signal processing, which means DSP, digital signal processing. Reduce fractal leakage during filtering and frequency domain analysis. In digital processing, DSP, the Hamming window is used as a smoothing technique to reduce fractal leakage during filtering and frequency domain analysis. And next, gradually check signal amplitude to 0 at the edge. So, it gradually check the signal amplitude to 0 at the edge, preventing sudden change with processing finite lag signal. This smoothing effect selectively reduces spectral leakage, especially in discrete pulse transform (DSP) and phase filter design. The next provides sudden change in infinite lag signal processing. So this part, the Hamming window provides a good balance between increasing resolution and side lobe recognition, making it widely used in filtering, spectral analysis, and speech processing. As you can see, we have 1, 2, 3, 4, 5, 6, 7 points. So the mathematical formula is W bracket N 0.54 minus 0.46 cos bracket 2 pi n over n minus 1 bracket. So the value of n is equal 0, 2, or 1 and negative 1. We have 1, 2, 3, 4, 5, 6 points. The first point is use a simple concise-based function easy to implement. The window as a simplified consumer-based function, making it easier to implement while maintaining good performance in signal processing applications. It's smooth, the shape curve with routed edge, reduce signal discontinuous. Next, has a smooth reduced bell-shaped window. Third, reduce shadow change at the signal edge. Next, minimize spectacle lag in the frequency domain and provides better side lobe explanation than rectangular window. And lastly, commonly used in the pre-filter design and spectral analysis. So we can explain when transferred into the frequency domain using the Fourier transform. This smooth transition helps reduce spectral lag. Compared to the rectangular window, the Hamming window provides better side lobe explanation and improved frequency resolution, making it widely used in field filter design and Fourier transform applications. So this is characteristics of Hamming window. The character we have 4. The first, side lobe separation, and second, main lobe width. Third, reduced ringing effect, and fourth, smooth time domain shape. The fourth 1, 2, 3, 4 point is I would like to explain with you. The side lobe separation is provide good side lobe explanation. Significantly reduce unwanted frequency component. Perform better than the rectangular window. Next, the lobe width has a wider main lobe compared to the rectangular window, and slightly reduce frequency resolution and improve overall filter smoothness. Reduce ringing effect. It means a smooth tapering at the edge produce that ringing and result is a smoother frequency response. And lastly, smooth time domain shape. It means has a gradual decrease in amplitude at the beginning and of the window. Reduce aircraft discontinuous in the signal. So for advantage and disadvantage Hamming window, we have disadvantage residual spectacle lag, smoothly type edge of the signal, reducing discontinuous and sparing of energy. Better side lobe separation. If side lobe level is much lower than rectangular, giving a clear spectrum. Widely applicable, often used in the digital picture signal, speed processing, and signal reconstruction. For the advantage is strictly with main lobe, frequency resolution is greatly reduced because the lobe is with than rectangular window. Next, more computation with calculation computation effect effort than rectangular. And lastly, trust of between resolution and network later, but sacrifice some ability to distribute closely spaced frequency. Thanks for thanks for my case, Haziq. My name is Ahmad Sadaka bin Ahmad Asri, dan my number is B122410526. After this is the graph for the handling window, as you can see, we got the time domain and frequency domain. And you can see this is time graph. And then you can see the amplitude and sample and magnitude and normalized frequency. Move on to the next slide. Coming into to the rectangular window. Firstly, rectangular window, the simple type of the window function in the S3, the user interpretation of the use and the SIR with the design. Secondly, rectangular window is created by the selecting six value of function and assigning them on the value of 1. On the center outside, the selected ones are set to click. Rectangular windows form upright formation without smoothing at the edges. The rectangular window narrow and low white good frequency solution and has a high side load level for spectrum liquid and the ring effect. This is a mathematical formula for the rectangular window. We got the omega n and the factor 100 and n minus 1. N is a window length and the n updated is the sample index. The rectangular window is mainly used for simple analyze and algebraic computation. Simplicity is more important than simply domain. This is the characteristic from the window. The characteristic has a 4. With the high side load level, strong ring effect, 4 side load for narrow main-load width, we got a narrow main-load in the frequency domain and has a white good solution. For high side load level, it produce high side load and cause a significant spectral utility and allow unwanted frequency to appear in the output. And thirdly, for strong ring effect, it has an abrupt signal combination which introduces noticeable ringing, such as this phenomenon, and result in a less smooth frequency response. And lastly, for the 4 side lobe subfunction, it does not effectively suppress side lobe. Okay? And then it provides low stop band attenuation and is less suitable for application requiring high stop band attenuation. Okay, so move on to rectangular window. For characteristics for rectangular windows, we have 4, which is pilot subtraction, main load width, reduced ring effect, and most time domination. Okay, the explanation for this, the explanation for the side lobe subtraction, we got provide good side lobe attenuation, significantly reduce unwanted frequency compensation. And then it can perform better than rectangular window. Okay, got it? And then for the main lobe area, it has a wider main lobe compared to the rectangular window. and it slightly reduces frequency resolution, and it improves overall movement. So you got no noise if you show all the unwanted frequency. And then for the reduce ring effect, you have to smooth tempering at the edges, and you can produce less element that again this phenomenon. Okay, and the result is smoother considered. For the first time limited, we have a gradual decrease in the amplitude at the beginning and the end of the window. Lastly, to reduce the abrupt, this contains speech in the signal. That's all for the window. Okay, this is a advantage and disadvantage for the rectangular window. For the advantage, you have the simple and the easy to implement, like only multiply the signal by 1 and no extra computation needed. And then secondly, it's a maximum frequency resolution. The main load in the frequency, you can respond in narrow that you can distinguish how to take frequency. And then it's good for the short signal. When the signal segment is short and listening is less of a constant in n, for the disadvantage, you got a high spectrum usage. As a bird start end of the window to the discontinuity spreading energy into the unwanted frequency. Secondly, the high side lobe level. Energy in the side lobe can mask smaller signal near from potential command. Thirdly, not suitable for sensitive application. Poor performance for filter design. FFT analyze and fixed audio processing if apparently is incorrect. Also for advantage and disadvantage, rectangular window. And then we got the graph for rectangular windows. We got high lumen and frequency lumen. And the amplitude, control, magnitude, and dB normalized frequency. As you see, the time domain graph is at at one amplitude, and then for the frequency domain, we got so many frequencies, from the 50 minus dB to the minus 250 negative 250 frequency. Earlier the method coding begins by clearing the workspace, comma window, and the closing of the assistant to get the ensure a clean environment before the execution. The sampling frequency is set to 1000 Hz, the cutoff frequency to the 100 Hz, and the filter length to 51, which is triggered as a up number to maintain symmetry in the FIR cycle. And the idea of the low pass is the impulse response to the impulse response to is the calculate using the sign function. As the cutoff frequency is normalized and the center is handled separately to avoid division by zero. Next two window functions are applied: the rectangular window and the hammer window. Those windows are multiplied with the ideal impulse response to produce two different appliances. Okay, after they design the filters, their frequency responses are obtained using the frequency function, which allow observation of how each window affected the filter's magnetic response. The test input signal consisting of low frequency component which is 50 Hz, and the high frequency component, which is 200 Hz. Is generated to evaluate the filter performance. This signal is passed to both SR filters using the filter function, producing two output signals. Finally, the impulse responses and the time domain output are plotted for both filters. The results clearly show that the rectangular window filters include more ripples and distortion, while the Herman windows filter produce a smoother output due to modified led suppression, making it more suitable for practical signal processing applications. This is a parameter design, something mostly which is still early, which is 1000 Hz, and the power frequency which is 100 Hz. Filter length is 51, and the filter type is FIR. Okay, this is the output for the rectangular window. As you can see, we have input response, time domain, and frequency domain. This slide shows the frequency response of the FIR low-pass filter designed using the rectangular window. On the graph, you can observe a relatively short transition between the pass band and the stop band. This indicates that the rectangular window provides a good frequency selection. However, we can also see a significant difference in the stop band region. These ripples are caused by the high side load level, which results from the abrupt transition of the impulse response. This phenomenon leads to spectral issues, where unwanted high frequency components are not sufficiently emitted. Okay, next, this slide presents the frequency response of the FIR low-pass filter designed using the Haziq window. Compare the rectangular window, the transition band is slightly wider. However, the most noticeable improvement is the significant reduction in the stop band region. This indicates better side lobe attenuation, which is a key advantage of the Haziq window. The smoother tempering of the impulse response reduces discontinuity and minimize spectrum leakage. As you can see, this is the application for the Haziq window and the rectangular window. The application for the Haziq window, we have the speech processing, audio signal filtering, noise reduction system, spectral analysis. And for rectangular window, we have the basic FIR filter design, application, traditional and laboratory experiments, simple spectrum analysis, and low complexity signal processing system. For the Haziq window, speech processing, used in the speech analysis and the recognition system to the reduce spectral leakage and the performing FFT, for transform or on-chip signal. For the audio signal filtering, it applies in the FIR audio filters to achieve smoother frequency responses with reduced noise and leakage. For noise reduction systems, it helps suppress unwanted activity components due to discrete type load attenuation. For spectral analysis, it's commonly used before the Faris transform to obtain cleaner and more accurate frequency spectrum. For the rectangular window, basic FIR filter design used in a simple FIR filter, where the simplicity is more important than frequency performance. For the educative and laboratory experiments, commonly used to demonstrate windowing concept and spectral leakage in the DSP, digital signal processing part. For the simple spectral analysis, we apply when the high frequency region is required and the side lobe suppression is not necessary. For the low complexity, the signal processing system is suitable for the system with the limited processing power. The troubleshooting is windowing using professional in FR design to make the idea to practical and stable with the alignment of the characteristics. The rectangular window has a high side load, facilitating efficient, control speed, and strong make it less effective for passive operation. The hanging window reduces the side load and the facility due to graduate temperature. First, boosting particular response. Although the hanging window has a slightly wider loop, it is lower projectability solution is more suitable for practical applications. And lastly, hanging windows are preferred in applications like house systems, system light, and much other systems. That's all for